All right, we're going to continue with Chapter 3, Section 3. In this video, we're going to be doing synthetic division, and we're going to touch on the remainder theorem. All right, so in the previous lesson, we had discussed long division. The same problems that we can do with long division, we can also do with synthetic division. The only caveat to that is you're only going to be able to use synthetic division when your divisor is something of the form of x minus c. Right, so for example, if your divisor is something like x plus 2, you can write that as x minus negative 2, right? And this is going to be your c value, right? C doesn't really have any meaning. It's just a constant, right? So another example, like if you have x minus 1, right? Minus 1, this is going to be your c value, your constant value. Like I said, same way with long division, it's easier to just go through the motions of it, doing some problems, right? But you can refer back to these steps if you need, right? But the key points are pretty similar. We're going to arrange the polynomial in descending powers, and we absolutely need a 0 coefficient for any missing term, right? So I know I said with long division, you can maybe get around it, like you don't, like it might make the problem a little bit harder, but you can get away with not putting in a 0 for any missing term. But here in synthetic division, you absolutely need that 0, otherwise you get the answer completely wrong. And then the rest of these steps, right, so from 3 onward, right, is going to make more sense as we do them, right, and I'll show you how it's going to work. All right, so let's look at this example. Notice our denominator is in the form of an x minus c. So x minus c, in this case, we have an x minus negative 1, right? X plus 1, we're going to use the opposite sign of what we see here, right? So this is going to be our c value. And the setup is going to look as follows, right? So it might look a little different from person to person. I make a little box at the top, and I draw a line. In this box is going to go your c value. Your c value is negative 1. And right beside it are going to go the coefficients of your dividend. Right, so here your dividend is x squared minus x minus 2. Your coefficients are going to be a 1, negative 1, and your constant is negative 2. And you're just going to write those. You don't need any of your x squareds, x's, or anything. You can just write 1, negative 1, and negative 2. The process is as follows. We're going to bring down the first term, right? Don't do anything to it. If it's a 1, it's going to stay a 1. And we're going to bring up another term, right? But it's going to be what we get when we multiply this 1 by this number in the corner right here. 1 times negative 1 is negative 1. And then we're going to combine, right? So that little blue line that I drew is just telling us we're going to combine those two numbers, right? So this negative 1 and this negative 1, we combine and we get a negative 2. And then we repeat the process. We're going to bring a number up here, and it's going to become a negative 2 times, right? So this negative 2 times a negative 1 is going to get us a positive 2. And then you combine. Negative 2 plus 2 is 0, right? And so this number that you're left with, this is going to be your remainder. And these numbers, the 1 and the negative 2, are going to become the coefficients of your quotient. All right, so we're going to stick those numbers in a little polynomial that we get as our quotient, and it's going to have a degree that is 1 less than the dividend. All right, so our dividend right here is an x squared. Our quotient should be a regular x. All right, so we should see an x somewhere, and the coefficient of that x, we're going to go in order. Right, so the coefficient of that x is going to be a 1, right? So we're going to have a 1x. And then our second coefficient, right, our constant in this case is going to be a negative 2. So we have an x minus 2 as our. All right. And as you can see, it's the same thing that we got when we did long division. All right, so this is just another way to do it. Again, if you've never seen it before, it's going to look a little strange at first, but as you go through the motions, they're going to get way easier. All right, so this is another one that we did using long division. as you can see, our denominator is in the form of an x minus c. In this case, we have an x minus negative 3. So our c value is going to be negative 3. So set up our box the same way. It's going to go in negative 3. I'm going to draw the line. And then beside the negative 3 is going to be the coefficients of your dividend. It's going to be a 1, a negative 1, and a negative 2. So I'm going to draw 1, negative 1, negative 2. All right, I'm going to bring down that 1. And then what's going to go up here is this 1 times this negative 3 right here. All right, and then 1 times negative 3 is negative 3. And then you combine negative 1 minus 3 is going to get you a negative 4. And then you bring this number up. But you're not just going to bring up the negative 4, you're going to bring up a negative 4 times the number in the corner. Negative 3 is going to get you a positive 12. And negative 2 plus 12 is going to get you a positive 10. Right, and this number right here, this is your remainder. And then these numbers are, again, the coefficients of your quotient. Since we started with an x squared, we should expect to see an x, right? So 1 degree less than our dividend. So x should be our highest exponent here, and that has a coefficient of 1, right? We know it has a coefficient of 1 because that's what we got when we did our synthetic division. That's the first number that we see. The second number that we see is this negative 4, and that one's not going to have any variable to it. It's just going to be an x minus 4. And our remainder we wrote as plus our remainder over our divisor. All right, so then that's your answer. And then you can verify. We did the exact same thing with long division, and we got the exact same answer. Okay, so you can see that when we get to some bigger expressions in our dividend, then hopefully we can see that synthetic division is going to be a little bit more efficient, right? So down the line, right, we're really just teaching you the skill here, right? But this really doesn't have any meaning to you guys other than can you divide polynomials, right? But this is going to have a lot more use later on in some later sections. And in some problems, we're going to have to do some division 3-4 times in one problem, right? So hopefully you can see that synthetic is, in that case, the way to go because it's a lot faster. And then some other sections down the line, for example, when we start graphing these equations, then long division actually might give us a little bit more information than if we were to use synthetic, right? So they each have their places, right? So again, we've done this example before with long division, right? So I'm just going to show you how it would look with synthetic, right? So our denominator is in the form of x minus c. In this case, it's x minus negative 2, right? Because we see a plus. So let's do the opposite of what we see, and it's going to be a negative 2 in your corner. And then beside it are going to go your coefficients of your dividend. So it's going to become a 5, negative 6, negative 28, and a negative 2. I'm going to draw the line. I'm going to bring down the first number, right? Not doing anything to it. And then what's going to go up here is this number that we just brought down times the number in the corner. So 5 times negative 2 is going to get you a negative 10. Negative 6 plus negative 10 is going to get you a negative 16. All right, you're going to want to bring this number back up here by multiplying it by negative 2. And negative 16 times negative 2 is positive 32. And negative 28 plus 32 is 4. All right, bring this number back up here by multiplying it by the number in the corner. 4 times negative 2 is negative 8. And negative 2 plus negative 8 is going to get you a negative 10. So again, this negative 10 is your remainder. And then these numbers here are the coefficients of your quotient. Now, we started with an x cubed, and we divided something that had an x to the first. We should expect our quotient to have 1 degree less than our dividend. Right, so we're going to start, this 5 is going to become the coefficient of a 5x squared, right? So 1 degree less than an x cubed. And then you go in order. After an x squared is going to be an x, and then after your x is going to be no x, right? It's just going to be a 4. And then your remainder, you're going to add your remainder over your divisor, so negative 10 over x plus 2. And then that's your final answer. Again, verify that we got the same thing using long division, right? It should be exactly the same. All right, so here's another example that we did with long division. And this was one, if you guys remember, this was one where we needed extra terms in place of the ones that we don't see. And I had said that in long division, it's not super necessary. I mean, there's ways around it. But with synthetic division, you absolutely need those placeholders, right? So for example, this one right here, we have an x cubed, right? That's going to be an x cubed. But after an x cubed, the next decreasing, or the next exponent, if you're going in decreasing order, is going to be an x squared. We don't see an x squared here. So we need to have a placeholder. So I'm going to have a plus 0x squared, right? Because that's the same as just as if it wasn't there at all, right? But that gives us a spot to put an x squared term. We're going to do the same thing with our x, right? We don't see an x in the numerator, so it's going to be a plus 0x. And then we have our constant of negative 1. And now I'm going to divide. So this is going to go over x plus 1. And then we can do our synthetic division as normal, right? Our divisor is of the form of an x minus c. And we have here a plus 1. This means our c value is going to be negative 1. So in this little corner, I'm going to put a negative 1. I'm going to draw a little line. And I'm going to do the coefficients of our numerator. And it's going to be a 1, 0, and 0 as our placeholders, and a negative 1. So I'm going to drop this 1, and we're going to do the same process, right? So we get a 1, all right, and then up here is going to go 1 times negative 1, which is negative 1. 0 plus negative 1 is going to get you a negative 1. What goes up here is negative 1 times negative 1, and that's a positive 1, and 0 plus 1 is 1. What goes up here is going to be 1 times negative 1, which is negative 1. And negative 1 minus 1 is going to get you a negative 2, right? And this right here is your remainder. And we started with an x cubed, divided something that had an x to the first, so we're going to have one exponent less, right? So our first term right here, our 1, is going to be the coefficient of an x squared. And then this negative 1 right here is going to be the coefficient of an x. And then this one right here is going to be our constant. And our negative 2 is our remainder, so I'm going to write plus negative 2 over our divisor. And then, just like all the other examples, that's exactly what we got when we used long division. Now, in class, I just moved along, but I'll show you guys what would happen if you didn't put the placeholders for those zeros, right? So if you didn't, and this is not the way to do it, so you would set it up the same, negative 1. But let's say you skipped those zeros, you didn't put those placeholders. You would have a 1 and a negative 1. And then let's see what happens. If you bring down that 1, all right, you get 1. And then 1 times negative 1 is going to get you a negative 1. All right, so you get this. And if you have kept up to speed so far, you would know that this is your remainder. All right, but this 1, I mean, it doesn't give us any sort of information about the rest of our quotient, right? This is incomplete. This is only part of our quotient. It's not the whole thing, right? And we want our quotient to have something with an x squared, but we don't have any other terms, right? So you can see that this 1x squared plus our remainder, right? That's clearly not the same as what we got here, right? So doing it this way, our answer is incomplete, and this is incorrect. This is completely incorrect. So get into the habit of putting the zeros as the placeholders. Otherwise, you're going to get your answer completely wrong. All right, so this looks like a lot bigger of a problem. It's not super difficult, but this is our one exception to using synthetic division, right? Here we can't use synthetic division. We have a quadratic in the denominator, but we were only able to use synthetic division if we had just something of the form of an x minus c. We don't see that in our denominator, right? So we can't use synthetic division here. We have to use long division. All right, so our setup with long division was our divisor on the outside and our dividend on the inside, right? So 2x to the fourth plus 4x cubed and so on. And then the first thing that we're looking for is something that we can multiply this divisor by to get a 2x to the fourth. All right, and that's going to be a 2x squared. All right, so multiply 2x squared to your divisor, and you're going to get a 2x to the fourth plus a 4x cubed minus a 6x. All right, and then so from this point, what we did was we subtracted this from these terms up here, right? And subtracting just changes the sign of everything, right? So this is going to become a minus, this is also going to become a minus, and this becomes a plus. All right, and then negative 2x to the fourth cancels out. 4x cubed also cancels out. It doesn't have to, right? But the one that absolutely does have to is our 2x to the fourth, right? In this case, 4x cubed also canceled out. And then negative 5x squared plus 6x just leaves you with an x. All right, we have 3 terms in our divisor, so we should see 3 terms as our next, oh, I forgot x squared. All right, x squared. All right, so we should see 3 terms in our next round of this. All right, so let's bring down both of these. All right, so now I have 3 terms to work with, and now we're trying to see what can I multiply an x squared with to get an x squared. It's just 1, so I'm just going to write a plus 1. And then 1 times our divisor is going to get you an x squared plus 2x minus 3. And then now we subtract, right? So change the sign of everything. And then the x squareds cancel out. And then you're left with an x plus 1, right? And that's your remainder. So your final answer is going to be written as a 2x squared plus 1 plus x plus 1 over your divisor. All right, so something like that. All right, so again, something like this, you wouldn't be able to use synthetic division. You would need to use long division. All right, so the last topic for this lesson is going to be remainder theorem. This is just another application of synthetic division. And a remainder theorem basically says if a polynomial f of x is divided by x minus k, then the remainder, all right, this should say equals. The remainder is going to equal our function value evaluated at k. Or I'm sorry, our function evaluated at k. All right, and we're going to see what this means in the next slide. All right, so just looking at these problems, these look like things that we've seen before, right? So these shouldn't be super difficult. If you want to find f of negative 2 for number 10, all you have to do is just replace every x that you see with the negative 2. So I'm just going to do that just to show you what we get. So f of negative 2 is going to get you a 3 times negative 2 cubed plus 8 times negative 2 squared plus 5 times negative 2 minus 7. All right, so just evaluating this, we'll do our order of operations. We get 3 times negative 8. All right, so do our exponents first. Plus 8 times 4 plus 5 times negative 2 minus 7. All right, now do our multiplication. We get negative 24 plus 32 minus 10 minus 7, and then just combine left to right. So we get 8 minus 10 minus 7. And then we get negative 2 minus 7, which is negative 9. All right, so this is what we get when we evaluate f of negative 2. There's nothing wrong with doing that, right? You guys know how to do it. It's nothing super complicated. But sometimes the numbers get super large, and sometimes it's very tedious. It takes a lot of time. Another way that you can do it is by remainder theorem. We can say that if we use synthetic division using this number right here, our remainder is going to get us our function value, right? So why don't we try that? I'm going to do synthetic division, and I'm going to put this negative 2 right here in the corner, and then right beside it is going to go the coefficients of our polynomial, right? So we're doing synthetic division. And then we get 3, 8, 5, and negative 7. Right, so let's just do synthetic division and let's see what we get. Right, drop down the 3, and then what goes up here is going to be 3 times negative 2, so negative 6. 8 minus 6 is 2. And then 2 times negative 2 is negative 4. And then we get a 1. And then 1 times negative 2 is negative 2. And then we get negative 9. All right, and we got the exact same thing as if we were just evaluating, plugging in negative 2 and evaluating the expression, right? We got the exact same number by doing synthetic division. And synthetic division actually took a lot less work. All right, so f of negative 2, we got negative 9. We got it both ways, all right? So this is just an application of synthetic division. This is when maybe it would be a little bit useful and a little bit helpful. All right, so we can see with the next one. The next one, we would get a lot bigger numbers by doing 4 times 4 cubed plus 10 times 4 squared, right, and so on. So let's just use remainder theorem, right? So let's put our 4 in the corner, right, because we're trying to find f of 4. And let's write our coefficients. All right, bring down the 4. And then what goes up here is going to be 4 times 4, which is 16. And 10 plus 16 is going to get you 26. All right, that's something that maybe you can do in your head, right? It should get you 104, but if you can't do it in your head, you would probably just do that on the side, which isn't any more work than, or maybe is even less work than if you were to do this entire expression, right? So we should get 104, right? And then negative 3 plus 104 is going to get you 101. And 101 times 4, again, maybe you can do it in your head, is going to be 404. And then we get negative 8 plus 404 is going to get you 396. All right, so f of 4 is going to be 396. All right, so notice that didn't take too much time, right? If you were to do it the long way, so maybe you did f of 4, and we did 4 times 4 cubed, plus 10 times 4 squared minus 3 times 4 minus 8. All right, we get 4 times 4 cubed is going to be 64. 10 times 4 squared is 16. All right, minus 3 times 4 is 12. Minus 8. 4 times 64. If you can do that in your head, great. If you can't, you would do it off to the side. You would get 256. And then 10 times 6 is 160. And then minus 12 minus 8, go from left to right. 256 plus 160 should get you a 6 right there, 416, right? Minus 12 minus 8. And then we get 404 minus 8, and that gets us 396. All right, so we get the exact same thing. They were both very doable, right? So in these examples, if you were to just plug in your value and evaluated it, it's not anything too crazy, right? But maybe the numbers get so large and maybe you need to double check your work, and doing it this way is going to get you the exact same thing, right? So this is an application of synthetic division. This is when it might be useful to you guys when you're just evaluating function values and you're putting it in big polynomial expressions like this. All right, so hopefully this helps. And then the next lesson, we're going to finish the rest of these slides and we're going to do factor theorem.